Hello everyone, in this video I am going to explain heap sort, the process of heap sort, and we will be seeing a code in C++ language for sorting and given array using heap sort. So let's get started. Heap sort algorithm is based on selection sort algorithm. As in selection sort, we select the maximum element and put it at the end of the array. The maximum element at the end of the array, and then we find second maximum element and we place it at the second end position of the array. Similarly, in heap sort, we are going to find the maximum element and put it at the last of the array, and then the second maximum at second last position. So it is based on selection sort. In selection sort, linear search is used for finding the maximum element, and this is for all the indexes, so its time complexity come out to be big O of n square. But in the case of heap sort, uses min heap or max heap data structure, so it does an optimization over selection sort, and so its time complexity get reduced to big O of n log n. Let's now discuss the steps that are involved in heap sort. So step 1. In step 1, we create heap, that is min heap or max heap from given array by rearranging the elements of given array. So actually what we are doing here is that we are restructuring or rearranging the given array itself. We are not using any extra space, as it is an in place sorting algorithm. It is also called in place heap sort. So in place algorithms are those algorithms which do not use extra space. It uses only the space that is provided with the given input. So in step 1 we have created heap. Now in step 2, we will swap root of heap with last element and remove last element from heap. And in step 3, we will do heapify. I will later explain about the operation heapify. So we will keep repeating these steps until our array becomes empty. Our heap becomes empty, but array remains with the elements in sorted order. Now let us take an example to understand the process in detail. So suppose this is the array given to us containing elements 10, 15, 50, 4, 20, and we have to sort it. So let's copy it here: 10, 15, 50, 4, 20, and mark the indexes 0, 1, 2, 3, 4. So step 1, in step 1 we are going to build a max heap, as we are going to sort the given array in increasing order. So first of all we will make a complete binary tree, that is it has 5 elements. To first we will put the first element, then next element, then next element, and in the left now we'll put the further elements in the left node, that is after 50 we will put 4 and 20 here, node 4, node 20. Now let's mark the indexes. It is 0, 1, 2, 3, 4. So in step 1, to convert it into a max heap, we are going to perform heapify operation on each of its internal node. So we will start it from the last internal node. We can see 420 and 50 are leaf nodes. These are not internal nodes. The last internal node is 15 and 10 is also an internal node. So we will start with 15. Well, first of all we will heapify 15, then we will heapify element node 10. So heapify index 1. In operation heapify, what we are going to do, we are going to check if this element is smaller than its node or not. Basically we are going to search which is the largest element out of these three elements, and we will put it at here at the root as the parent, and we will swap the largest of three elements with this node. So here 20 is the largest element among all these three elements, that is 15, 4 and 20. We will compare the node for which we are performing heapify with its children's. So here 20 is largest, so it will be swapped with its parent. So 20 will go there, 15 will come here. After performing heapify for index 1, we will get 10, 20, 50, 4, 15 will come here. Now again let's mark the indexes 0, 1, 2, 3, 4. Now how our array will look: 10 is at index 0, 20 is at index 1, 50 is at index 2, 4 is at index 3, and 15 is at index 4. 0, 1, 2, 3, 4. So basically we have rearranged the given array in this step. Now again we will perform heapify for this node, next internal node, means just previous internal node till we reach the root node. So we will perform heapify for index 0, means for this node. First we have performed for this node, now we are going to perform heapify for this node. So again we are going to check this node with its children, and we will find which is the largest element among all these three. If the root is the largest element, then we will not perform any swapping, we will move ahead. If it is not the largest element, any of its children is the largest element, then we will swap with it. So here clearly we can see this 50 is the largest element among all the three, so it will get swapped. 50 will go there and 10 will come in the place of 50. So our array will look like, our complete binary tree will look like 50 at the top, 20 in the right, 10 at index 2, and 4 and 15 will remain as it is. Now again let's mark its indexes 0, 1, 2, 3, 4. Status of our array: 50 is at starting index, then 20, then 10, then 4, then 15. Now we have successfully created a max heap out of given array by rearranging the elements of the given array. Here we can verify it as a max heap as 50 is greater than all of its children, that is 20 and 10, and 20 is also greater than all of its children, that is 4 and 15. So it is a max heap. Now I want to discuss that how we can find out which node is the parent of which node and which node is children of which node. So in this pictorial representation we can easily find out, but for finding out an array we will use a formula. So these formulas will be used in code. So if we know the index of a node and we have to find the index of its children, so let's assume I is the index of a node, and then left child index will be 2 into I plus 1, and right child index will be 2 into I plus 2. So from the index of a node we can find out the index of its left child and right child. Similarly, if we have given a node of a children and we want to find the index of its parent, suppose this I is the index of a node and we want to find the index of its parent, then we will use the formula parent index, that is I minus 1 upon 2. If it is not completely divisible by 2, we will not consider the decimal, we will take the whole number. Now after creating successfully a max heap, we will move on to the next step, which says that we will regularly swap the first and last element of the array, and we will remove the last element from heap. So we will swap first and last element from heap, and we will remove the, after swapping we will remove the last element from heap. So here in this situation our last element is at index 4, so we will remove array 4 and we will swap array 0 and array 4. So these two will get swapped, and after swapping this will get removed from the heap. So after swapping, 15 will come at the place of 50 at the root, and 50 will come at the place of 15, that is at the last node, and it will get removed. So our heap will become like this. Now it is not a max heap, as we have made changes in this max heap. Now 15 has come at the root, it is smaller than its child 20. So we will again call heapify for this root node to fix the changes that we have made and to again make it a max heap. So after calling heapify, this will get swapped, 20 will get swapped with its parent, and 20 will come here, 15 will come at the place of 20. So it will become a max heap after calling heapify for root node. So again it has become max heap. Now again we will repeat the previous step, that we will swap the first, that is root element, and last element, and after swapping we will remove the last element from heap. So we have swapped 20 and 4, so 4 will come here at the place of 20, and 20 after coming at the last place it will get removed. So 20 will come here, and 50 has already come to its original and final place. 20 will also come to its final place. So after performing the operation 2 times, we will get 2 maximum elements at the 2 last positions. Now our heap has 3 elements, and again we have disturbed its heap order property. So again we have to call heapify for the root node. So the operation heapify will compare all the 3 nodes, that is parent with its child node, and maximum will come at the root. So here 15 is maximum, so it will come here at the root, and 4 will come in the place of 15. So after heapify, our max heap will look like this. So now again we will swap 15 and 10. We will swap array 0 and array 2, as array 2 is the last element of the heap. So after swapping we will remove array 2, that we will remove 15 from the heap. So after swapping and removing, our final array will become like this up to here, and 2 elements will remain in heap. So as it is already a heap, so heap function will not make any changes in the given heap. After calling heapify for the root node, our max heap will remain as it is. Now we will perform the swapping for first and last element of the heap. So 10 and 4 will get swapped. 4 will come at the place of root, and 10 will get removed. It will come at its final position. So only 4 is remaining in the heap, so we'll stop here, we will stop our loop here. So now after performing swapping and removing, we will get our sorted array finally.
Now let us see the code of heap sort. So here I'm defining an array on which I'm going to perform heap sort. So it is containing elements in random order: 32, 12, 11, 1, 6, 7, 100. Now finding out the size of this array, int len is equal to size of array divided by size of first element of the array. So after this I will call heap sort. On the array I will pass array and size of array, that is len. And after calling heap sort, for seeing output I am putting here a for loop. So it will run from 0 till length of array, and I will see out here array I with some space. So now our main function is completed, and now I'm going to write function heap sort. So as it is not going to return anything, I will write void heap sort. It will receive a array and size of array. As we have seen that in first step we are going to build a max heap out of a given array. So in the first step we will build a max heap for sorting the array in increasing order. So for doing so I have to put here a for loop that will start from the last internal node. Now we have to calculate the index of last internal node. We know that we the last node of the heap will be n minus 1, and we want to find its parent, as it is going to be the leaf node, and last internal node will be its parent node. We know that we have discussed earlier that if I is the node of the I is the index of the parent node, then with the help of this formula I minus 1 divided by 2 we can easily calculate the index of its parent. So here the index of child is n minus 1, so we'll in the place of I will put here n minus 1. So we'll put n minus 1 here, so it will become equal to n minus 2 divided by 2. So it will become n divided by 2 minus 1. So we'll use this is the index of the last internal node. So we'll move from the index of last internal node till root node, and we'll keep on calling heapify for each internal node. So for doing so I'm putting here a for loop. So it is going to start from n by 2 minus 1 till root node I minus minus. So we'll keep on calling heapify for array and size of array, that is size of heap here will be n, and in the place of the index of the root of subtree we'll pass I here. So after this for loop get executed, we'll get a max heap in the given array itself. So uh, after performing this is the step 1. After performing step 1 we will move on to step 2, and in step 2 we have to swap the first element of the array with the last element, and we'll remove the last element from heap. So again I am putting here a for loop that will start from the last element, that is its index is n minus 1, and I will do up to root node I minus minus. So I'm going to swap array at 0, that is the first element, with last element, that is array I. So this loop will keep on swapping the first element and last element repeatedly, and after swapping I will call heapify for the disturbed root node. So I'll pass here array, and in the place of size of heap I will pass I, as we have to keep on decreasing the size of heap. So after this I will pass the index of the node which we have to perform heapify, and here in this case we have to perform heapify on the root node, so I am passing the index 0, which is the index of the root node. So now our heap sort function is completed. Now heapify function is remaining, so I'm writing here a heapify function. Void heapify is not going to return anything, so it will remain void. It will take array as input, and size of heap, and index on which we want to perform heapify. So initially we will assume that largest node is the root node. So now from this root node I am going to calculate, from the index of this root node I am going to calculate the index of its child nodes, the from the formula that we have seen earlier, that is, for calculating the index of the left child we will use 2 into I plus 1, and for calculating the index of the right child we will use formula 2 into index of parent, that is I plus 2. So now we have the indexes of the root node, left child and right child. Now I'm going to compare all these, and I'm going to find out the largest of these three. So here I'm comparing. So I'm putting a check. Left remains within the heap, and after this, if left node is greater than here largest is the index of the root, so our largest index will get updated with the index of left node, and we will again check with the right node if right is within the array and right node is greater than the root node. Then we will update this largest index with index of right node, that is right. Now I will check here if our largest index, that is containing the index of root node, is updated or not. Not equal to I. If it is updated, then it will not remain equal to I, that we have initially put I in it, so it will not remain I. It will get updated with left index or right index. Then we have to swipe it. If it's not get updated, then we will not do anything. We will simply come out of this heapify function, means our given complete binary tree is already a heap. So here we will perform swap. We will perform swap between the root node and the node which is largest. And as we have swapped and we have disturbed its child node, then we will call recursively heapify for the child node that is either left or right, so it will again become heap, the left subtree or right subtree. So heapify, we will pass array, we will pass size, we will pass here largest, that is the containing the index of either left subtree or right subtree root. So now our heapify function is also completed. Now we can check if this code is working or not. Now I'm saving it. and running it. So it's showing some error. So here I've done some mistake, and at 29 and at 19. After correcting, let's see again at and 19 here also. Now I'll check. So this is our array initially, and I think this is the correct sorted form of this given array. So this heap sort code is working fine. Hope you understand the concept of heap sort. Thank you.